Hello there, 7th grade. Welcome to section 613. It's going to be the third and final section of this week that I'm going to be going over. This one is a important one. It is called one variable inequalities. Specifically, where do the solutions begin and end? Now, some of you may have already done this at the end of the 6th grade textbook, and that is fine. This is a topic that is going to continue to be taught and gone over, and you are going to have to go over this in depth. So what we're going to be looking at is, how do you tell what is a solution to an expression, and how do you tell when that solution ends or when it stops existing? Now, there's a lot of stuff in here about algebra tiles and which one is greater than and which one is less than. And overall, what I want you to consider about is the fact that you will be using number lines. You will be having to use a number line to determine where is this problem true or what is a solution to this. Now, I personally am not going to be going over too much of the solving expressions here. I will talk about those a little bit, where they say, hey, we are telling you that this left side is greater than this right side. So they tell you that this 2x plus 3 plus 1 plus a negative 1 is greater than x plus 5. And then your goal is to try and figure out what values make this true. And this is a really poor example to start with. So what I want to do is, let's just take a step away from the way the textbook is explaining this, and I'm going to give you an expression where I say x is greater than 3. Okay. If I give you this very straightforward expression for x is greater than 3, and then what I'm going to ask you to do is to provide me with a single number that makes this expression true or valid. So you want a single x value that makes this true. And you're going to say, well, okay, duh, I can just tell you x equals 5. Well, yeah. Does that work? Is 5 greater than 3? Well, yeah, duh, that's true. Okay, well, what if I did x equals 7? Yeah, because 7 is greater than 3. That's also true. So when I say what values make this true, you're like, well, 5 works and 7 works, and really anything bigger than 3 works. So you're going to end up saying, oh, well, duh, my answer is any x value greater than 3. And so they're going to be like, okay, Mr. Wood, why are you wasting my time with this? Why are you bothering to say, tell me a number bigger than 3? And so the follow-up is, okay, how do you show x greater than 3 in a way that actually works? So I'm going to clear this out, and I'm going to say, okay, well, if I want to show all x values greater than 3, you're going to do this by using a number line. And some of you have done this, again, like I said, you've done this in 6th grade a little bit. The important parts of the number line are at 3. And you can draw number lines like this, by the way. You can just put your most important part there. Okay. Whenever you try to mark if it is greater than 3 or whatever, you're going to fill in either a filled in circle or a open circle followed by an arrow in one direction. Some of you may have this face on because you remember doing a little bit of this. That's fine. You're going to be doing a lot of these. You're going to be doing these from now until the end of high school. So this issue of like, well, what do you mean there's open circles and there's filled in circles? Well, why is that even a thing? Well, it's because if you are dealing with a problem that is so they go in both directions. So if I am dealing with a greater than and equal to or less than or equal to, and the other equations are just greater than or less than. And no, I did not intend to draw angry eyes, but I now have angry eyes. So at x is greater than 3, this greater than symbol tells me that I need to have an open circle on here. I need to make sure that at 3 it is a open circle that I work with. And the x is greater than, well, we did this earlier where you said, well, 5 was something that made it true and 7 made it true. And, well, like 4 makes it true and 4.5 makes it true. So you draw an arrow from that circle into this region of the graph. And you're going to use that to indicate that all of my solutions are in this section of the graph. This is the section of the graph that makes it true. Okay. Now, the book is also going to introduce you to finding what is called a boundary point. So you may have an expression that looks like this. 2x plus 3 is less than 10. Let's not do 10. Let's do 11. Okay. You may have this expression that says, well, 2x plus 3 is less than 11. And you're like, okay, I don't really want to just start guessing until I figure out where that important spot is. Like, you could totally guess. You could plug in like 5 and say like, well, does 5 make this true? Does 6 make this true? Oh, well, what's the answer? But in reality is you're going to be sort of, let's see, you're going to do this as if you had an expression mat. But we're just going to jump right into this. We're going to work on this as an equation where I'm going to say 2x plus 3 is equal to 11. Okay, you might say, well, why'd you change that? I'll get over that in a second. This is just a way of helping you solve this expression. Well, what is the opposite of adding 3 to something? It's subtracting 3. And your book is actually going to tell you to do this with an expression mat. And I'm going to say no. Your book's going to say, well, here's your expression mat and here's your less than. And then there's like 11 of these little ones tiles, which I'm not going to have you do. But I'll show you why. It's because, first of all, it starts to take forever. Even just sketching out these 11 real quick is going to be a problem. Okay, maybe I should have picked a smaller number. And then on the left side you have a 2x, which were these longer x tiles. And then a 3. And 11. So if you remember that strategy where you could remove equivalent tiles from both sides, it was one of our legal moves. I can take 3 tiles from both sides and I can remove them from the problem. They can be gone. Well, in math, I just represent that as a subtract 3 from both sides. Well, what is remaining on the left side of this? Well, 3 and negative 3 zero out. I'm left with a 2x. And then what's left here is 1, 2, 3, 4, 5, 6, 7, 8. Well, why draw the tiles over here? Why draw tiles when this requires a lot less work? So just keep that in mind. There are easier ways to do these than with the tiles. And now your question is, well, if 2 times a number is 8, what does that number have to be? If I said 2 times something to give me 8, and then I sat there waiting for too long, you'd all get frustrated because you realized that the answer has to be 4. Okay, why did you go over all of this to get 4? It's because 4 is what we call our boundary point. Okay, 4 is what's called the boundary point. So in this expression, you know that the important number occurs at 4. And at this point, all you have to do is say, okay, well, I know 4 is the important spot. It's the boundary point. And I know I had this less than symbol. So I know it's going to be an open circle at 4. And then your goal is to figure out, is it going to the left? Is it open circle going left? Or is it open circle going right? And so you have to figure out which one that is, and you do that by testing a point. Or just test a number. I'm going to test 6 because it's right here. Let's just test 6. You take the original expression over here and you say, well, 2 times 6 plus 3 less than 11. 2 times 6 is 12 plus 3 less than 11. 15 is less than 11, and just by saying it out loud, you realize that this is false. So I know that my arrow is not pointing to the right because this made it false. This was a false section. So my arrow points off to the left and goes that way. And you could test any smaller numbers than 4 and do that. Testing 4 itself will not work. So as much as there was in this section, I would much rather you be able to work through and then solve for the boundary point and then get there. On your homework for this, when you go to graph the inequalities on the number line, this is what I was talking about with this. This section where it says x is greater than 3, I know that at 3 is my solution. I know that because it's this sort of symbol, it is an open circle. And a number that makes it true might be 10, because 10 is indeed greater than 3. So I make sure that this arrow is going to point towards the section that makes it true. This graph here will start at positive 5. So at positive 5, I'm going to fill in the circle because it includes 5. That's what this line underneath it means, is that I'm including 5. And then all of the x's less than or equal to 5 are over here. Again, you just test any point here. Like, let's test 0. Is 0 less than or equal to 5? Well, duh, yeah, it's there. Please do not get in the habit of thinking, oh, I see a shortcut. There's a shortcut for this. I know that they exist, but it is a bad habit to get in. Don't say, oh, just because it's pointing left that the arrow goes left, or just because it's pointing right that the arrow goes right. I know that right now it's working, but don't use that sort of shortcut. A lot of people will think that they have that shortcut, or they were taught a shortcut for it. It's bad. Don't do it. That's most of what I got for you here. On the last little bit, if you can do these are fantastic. This one is going to be a very vocabulary heavy challenge on 6-31. You really should follow the first directions in here where it says read the math notes box in the lesson. A constant is just a whole number. 2 factors in this thing are 2 and 4x plus 1. Those are individual factors. And then 2 factors inside of the 4x are 4 and x. So be careful on those. That's all I got for you, 7th grade. Best of luck.